Well, the purpose of me creating this video is to highlight the main topics for our test coming up so that we can spend class time in practicing. So, our first topic here is, can you use Riemann sums to approximate the value of the area between the curve and the x-axis? So, as you'll notice, for each topic, what I'll have is it'll list the topic and then there will be an example. So here's my topic, and then here's the example, okay? So if I give you a function like 4x minus x cubed, could you sketch the rectangles and compute by hand midpoint rectangular approximation using that method? Or could you also use the right rectangular approximation method, the left rectangular approximation method, and also trapezoids? Now, if you need to review any of this, you can find these topics. This would be 5.1 for right RAM and left RAM, and then chapter 5, section 5 is trapezoids. Okay, now I would suggest you try this problem, and then on the next slide you're going to see then the solution to this problem. So here you can see that there is a diagram of it with the MRAM, okay, and then this is the answer. Now when you do this on the test, I am going to expect that you will have the setup for the MRAM and then the answer. So for example, here we've got 4 rectangles going from 0 to 2, so that means the change in x is equal to 0.5. So then I'm basically going to set up 4 areas of rectangles. So I'm going to have the base and then times the height. Now you'll notice the height is between 0 and 0.5, so it'd be 0.25. So I'm going to substitute 0.25 into the function, which would be 4 times 0.25 minus 0.25 cubed. And then I would do that again. The base of my rectangle is 0.5, but this time you'll notice the height right there is between 0.5 and 1, which is 0.75. So the function evaluated when the x value is 0.75. And I continue this, showing the setup for each rectangle. Okay, this would be 1.25, and then last of all, then we have the function evaluated at 1.75. Great. So, and then trapezoids. Can you use the trapezoidal method? So you need to have that area function memorized. Now let's move on to our next topic then. Oh, wait. That is a repeat, isn't it? Oh, no. What's different about this is that you notice that this is a numerical perspective of Riemann sums. So if you are given a table of data then, can you, from the table of data, extrapolate the rectangles using, or trapezoids using this? So for example, this problem is asking that you give an upper estimate and a lower estimate. Well, you have to ask yourself, which would give you the upper estimate? Well, just looking at this data, I can see that 0.019 is less than the last value. So if I were to do LRAM, I would get a lower estimate. And if I were to do right RAM, I would get the upper estimate. Okay? So going on to the next slide, you'll be able to see the solution to this. So when I look here, I do not have an answer for this one. But if you would like to try it and send me what you get for an answer, I would reply back to you. Oh, I thought, well, maybe not. Now, the second topic is, can you find the exact value of an integral by graphing the function? So this is a graphical perspective here. So I want to find the area between the curve and the x-axis of the function 1 minus the absolute value of x, going from -1 to +1. So first thing, you need to be able to graph an absolute value function. Well, I know that if it's negative, then my absolute value is going to open down, and the 1 says to move it up 1. So my graph would look something like this. And then I need to find the area of the region between the curve and the x-axis. So that would be then this region right in here. So I'm going to use my triangle formulas to find the area of that region. Okay, now moving right along. This was actually where I was going to show my work. Okay, climbers, so you would have a graph like this, and then you would find then the area between the function and the x-axis, okay? And the answer you should get would be 1. Now make sure you show all work and the solution. Okay, next topic. Can you find the exact value of an integral by using your calculator? That's right, all of you need to be able to use your calculator to find the exact value. So we are told here that we have a population growing at a rate of 3,000 over 1.0.25 t per day. By how many people did the population grow in the first 8 days? Now you'll need to be able to write this as an integral. So I want to go from 0 to 8. And notice the population, the units match. So it's in the first 8 days and it's per day. So I want to find the integral from 0 to 8 of the rate of change. Because we know that when we multiply the rate of change times days, then we will end up with the amount of population growth. So can you do that in your calculator? Now if you can, then you should be able to get this answer. So check your work and make sure you can interpret the answer. In other words, can you use the correct units of measurement? This would be that it would be the population's growing by 13,182 people. Okay? Because remember, whenever you take the integral of a rate of change, then you will get the number of units of whatever you are comparing as far as your growth, what is changing. Okay? Now, our next topic is, can you apply the properties of integrals? Now, recently we went through these in class, and we had to look at how to use these when evaluating integrals. So here are a couple of examples where you are given 3 facts, and then you have to use these 3 facts to answer a couple of questions. Now we spent quite a bit of time in class on examples like A and B. The next slide will show you the answers, so you can try those on your own. And then here, total area of the curve. Ooh, that's a good review question also, isn't it? You would have to graph that function, and then using your geometry, find the area between the curve and the x-axis. So here are the answers to the questions above, so you can check your work on that. Okay? Now, also, you need to be able to apply the properties of integrals graphically. So you notice here I have a graph of a function, f of x, and then we want to be able to find the area under the curve for this function given the specific examples. So for example, on A, can you find the area of the curve from -2 to 2? So that would be from -2 to 2. So I'm going to use my triangle formula to find that. Okay? Let's see if I can undo that. Oh, I need to use my eraser, and I'll erase it. There you go. Now, part B then says, can you find the area of the curve from 2 to -2? Now, what's wrong with that? Do you notice that the limits are out of order? So for a problem like that, then we would take the opposite, and we put the limits in the correct order, 2 of f of x. So again, we would be actually finding the area again of this portion, and we notice that it is a positive value, but because we need to take the opposite of that, so it would be opposite of whatever that area is. Okay? Now let's move on to C. Wish my eraser were a little bigger here. Okay, so C, we want to go from 0 to 6. So notice here we need to find the area of the curve of the triangle and then the area of the curve of the semicircle. Do you remember your formula for semicircle? Pi r squared, but that's half. So we would have to add the area of the triangle, and then you notice that the circle is underneath the x-axis, so it's going to be negative of a half pi r squared. Okay, and you would do it accordingly. Now you see if you can complete D, E, and F without any assistance from me. Okay, can you interpret the meaning of an integral? Like for example, if I tell you that this graph where the y-axis represents the velocity of a snail in respect to time, inches per minute nonetheless, and then the t will represent time, which will be minutes. Okay, so for this problem, would you be able to tell me the total distance traveled by the snail at 6 minutes? So in other words, how far did it travel in these first 6 minutes? Well, we know that this distance here would be to the right, then it stopped for a little while because it got pooped, And then let's see, 1, 2, 3, 4, 5, 6. And then it went backwards a few units. Now remember, distance is where I add up the total area. So I would add up the first section, region 1, and then add that to the absolute value of region 2, because even though you're going the other direction, you're still traveling. And the displacement would be of the snail in the 9 minutes then, that would be what is my change in position, okay? So the change in position. So here I went forward a certain number of units, and then I went backward. I don't know why I'm writing a plus sign. Then I went backward a certain number of minutes, or to the other direction, and then again I went forward. So what is my change in position? And that is it for today. So make sure that you do the practice problems in preparation for your test.